All right, so let's start. So a fisherman in a boat on a lake counts crests of wave passing the boat at a time interval of half seconds, which has been highlighted, and successive crests, half seconds between successive crests. Each crest takes 1.5 seconds to travel a length of the boat, which is 4.5 meters. Determine the frequency. So which means the frequency which we are referring to there is the F. Those are the symbols for frequency, like what we discussed yesterday. F, the angular frequency, omega, the phase velocity, V, and also the wavelength, which is lambda, like that, and the wave number K, the wave number K. So from our wave equations, we know that if you are given a wave, which means a sinusoidal wave, which means this is one oscillation. If I'm going to draw another cycle, it's one complete cycle. We indicated yesterday, these are the crests. And then what is at the bottom? The troughs, which is, those are the troughs, which are at the bottom. So if we are to repeat again another wave, continuing drawing another wave from where we are, which means we are going to continue the same sine wave starting from the origin, comes back. So which means these are the crests which we are talking about. The ones at the bottom are the troughs. So in our case, we're given that the period or the time between two successive crests. So which are the two successive crests which they are referring to? The top one. So we are referring to the top crests. Those are the two successive crests, which means the distance, which means the time starting from here, starting the time from this crest up to the second crest. So the second crest, which will be this one. That's the second crest. So the distance between two crests is lambda. So this is your lambda wavelength. And also the time between those two crests, that is the period, which is lambda, which is the same t, which means we are having also our lambda and t in the same period, half seconds. So the distance, the distance there, it will be lambda, which we are going to calculate, but we are given that the t in the first time, the t, the period t, this is our t, it's equals to half seconds. So this is the half seconds, which is we are referring to our t, which we are going to use. T is equals to half seconds. All right. So in calculating our t is half seconds, which means the frequency we are able to calculate using the formula for frequency, which I indicated yesterday. The formula for frequency, 1 over f. So if you want frequency, which means the formula for frequency, t is equals to 1 over f, like what we did yesterday. And also f is equals to 1 over t. So here we want f, so which means t is half, which is the same as 0.5 seconds. So if I want the frequency, I use the formula f is equals to 1 over t. So which means f is 1 over t, which means that 1 over 0.5 seconds, which means hertz. And another unit for hertz is per second. Per second. So hertz, or we call it per second, because the denominator is seconds, so it's per second. That is the unit for hertz. In symbol, it's per second, s to the power -1. Now you want the angular frequency, omega, it's 2 pi f. We explained about this, 2 pi f. which means now it's a matter of substituting. Set your calculator into radians mode. I indicated, must set the calculator into radians mode, 2 pi f. Frequency, it's now 2 hertz. You have calculated the frequency. So which means you come and substitute the 2 hertz, is 2 hertz. You put it there in the frequency. Pi, set the calculator to radians mode. Now you get your answer. The units, it's pi. The units, it's radians per second for angular frequency. Phase velocity, you can use V is equals to F lambda, which means, or you can say the speed is equals to distance over time, like what we did yesterday when I drew the triangle. I drew the triangle, which was like this, which was like that. If you want speed is equals to distance over time taken. In relation to our physics, how do we redraw that triangle? It will be like this. With respect to physics symbols, the distance which you are referring to will be the lambda. And then the speed which you are referring to is the v. The time taken is the t. That's why lambda was yesterday, lambda, which is our d, lambda was the same as the phase velocity multiplied by the what? By the period t. And then if you want the phase velocity, it will be the wavelength over the time. But in this case, we want the speed. So which means v, the speed, distance, it takes for the all the crest to complete the distance of the board, which means the crest travels the length of the board, which is 4,5. And how long is the crest going to take? The crest is going to take 1,5 seconds. So that is the time t. That's the time t. That's the time t. The distance covered is the 4,5 of the board. This is the distance covered. So if you want to calculate the speed, remember, speed is similar to the velocity, phase velocity. However, speed is a scalar. That's why we don't have direction. If it was only velocity, then it is having a direction to the right. So that's what we are referring to. So here, speed is equal to distance over the time taken, distance over time taken, which means our distance was 4,5 meters. The time is 1,5 seconds. You divide, you get 3 meters per second. Like what we said, if it's a velocity, which means to the right, you must have direction to the right. So it is magnitude and direction. But if they only ask about the speed, which means it will only have a magnitude without the direction. All right. Then the wavelength, that is the one which we were using this table here, the triangle. To say if I want wavelength, I say v times t, the phase velocity times the period t. The period t, you have been told that it's half seconds. So this is your phase velocity, which calculated period t, you multiply, you get 1,5 meter. Or you can use v is equals to f lambda. It's also allowed, where lambda is equals to v over f. You use the same. So our v was 3. Our f is 0,5, half. So which means when you divide by the frequency, the frequency was 2 hertz. Not half, but 2 hertz. So what is 3 divided by 2? You get 1,5, which is this one. In terms of wavelength, another formula. So there are two formulas. Lambda is equal to phase velocity multiplied by the period, or v is equal to f lambda. You get the same answer. Then the last one, we are calculating the wave number k. K, just set the calculator into radians. K is just 2 pi over lambda. Now we have your lambda, but the units is no longer radians per second. What is on top, they are radians. What is on the denominator, lambda, is measured in meters. So the units is just pi radians radians per meter. Then you can round off if you want to round off. So, but you can leave it like that. It's correct as well. All right. The recording for yesterday, it just disappeared on the website, so I don't know what happened. So that's why I had to compile a new one. So these are the basics. Very easy to understand. Nothing is difficult. Nothing is difficult. Frequency, 1 over period, 1 over t. You substitute 1 over t. Another unit for hertz, it's per second. When you want the angular frequency, it's just 2 pi f. You substitute the value of f, which was 2 hertz. Then your units in radians per second. The phase velocity, you are just calculating the distance over the time, which means the distance was 4,5. The time was 1,5 seconds. Now you have the phase velocity. The lambda, you are looking for lambda. You say phase velocity multiplied by the period t, you get 1,5 meters as your phase velocity. The wave number k is just 2 pi over lambda. Your units in radians per minute, per meter. That's it. It's done.